Hey, good morning or good evening, everyone. This class, I will talk about the new version of California Geological Survey Note 48. I mainly touched the updates from the previous version. So some of you, if you design the risk category 4 structures or buildings. So you might heard about the California Geological Survey Note 48. So it is a kind of concise two-page checklist format for the just to provide an overview of all hazards the CGS is concerned with. So this checklist is used for the review of engineering, geology, and seismology reports. So mainly for the school, hospital, and some kind of very important industry structures. So all of these are classified in the risk category 4 structure. So here's the reason have this two-page checklist is good for the consultants and their clients so they can understand the scope of the geologic hazard or seismology issues. California is a high seismic state, so make sure they are on the same page. And also, these two-page checklists are uniformly used by engineering geologists within the CGS. So when they review the consultant's report, so they have a kind of consistent uh, checklist to make sure they cover everything. So here are the difference with the previous version Log 48. So first, they have one additional item is called conditional geotechnical topics. So that will include the basement or retaining wall design, the foundations, and also the facts of construction on adjacent structures. For item 15, is very similar like the previous version, but right now they add side class D. So basically, because of if you guys watch my other videos, so there is a significant change on you design the seismic ground motion values. So the side class D, a lot of cases you might need to do the site-specific ground motion hazard analysis, unless you take the exceptions. I don't talk about too much detail about this. The only thing I want to point out, even in item 15, it mainly talk about the section 21.2, but actually, the section 21.1, the approach in that section is also allowed for the site-specific ground motion hazard analysis. Actually, that approach is the only approach now for site class F site. Once you have liquefaction, you have site F site, you cannot use the section 21.2 in the ASCE 7 for site-specific hazard analysis. Item 20, compared to the previous version, it added some verbiage about to address the differential settlement. So this is a kind of something new for the ASCE 716, the section 12.13.9. So it has some kind of specific requirement. It's more like for the performance design requirement. So first, let's talk about the conditional geotechnical topics. So it had three topics for the deep foundations. There are significant changes from ASCE 716, particularly for liquefaction-induced downdrag nodes. So I have a separate class to cover the changes on the deep foundation design. The C, is if you have the temporary shoring underpins, you need to evaluate what's the impact of these two adjacent structures. So here, just I mainly talk about the requirement for A. So the CBC 1878.2. So basically, that's kind of general requirements for the geotechnical investigation. Basically, what are the minimum borings you have to do for your project? And the section A.5.12, that's requirements for the lateral nodes on the walls. So any walls supporting more than 6 feet of backfill height, you need to, provide the seismic lateral pressure on the wall. So when you design the wall, you need to use a design earthquake. So that's a 2/3 of MCR earthquake. So risk-based earthquake. So this is consistent with other structure design. So the wall is still kind of type of structure. So when you do design the structure, you always use a design earthquake. However, when you do the analysis related to the soil, most time they are the maximum considered earthquake. At the same time, if you have liquefaction or liquefaction-induced lateral soil movement, you need to consider how would this impact the lateral soil pressure on the wall. So most time there will be an increase on the lateral soil pressure. So the 20, I kind of highlight the changes from the previous version. So now, other than you evaluate the liquefaction sediment, you also need to evaluate the seismic differential sediment. Actually, for the structure design, it's more concerned about differential sediment. If, the sediment is uniformly occur, so that won't damage or collapse the structure. One thing I want to point out, this item is applicable for both saturated and unsaturated layer of the soil column. So for some place in the California state, even the groundwater is pretty deep. You don't have liquefaction, but if your sand is very loose, so you still have the unsaturated sediment. So basically, the seismic loading will kind of compact your soil layers, so there will be some kind of sediment. So that one thing I want to point out. So another thing is the PGAM. So that will be based on the geomean maximum considered earthquake. So you will get from map, you get the peak ground acceleration, like the side class. You need to adjust that for side class effects. For the ASCE 716, in my previous video, I mentioned the factor to adjust the side effects, the FPGA actually increased roughly 10 to 20% compared to the previous version, ASCE 710. So again, the PGA M that was used for the liquefaction analysis, that will increase compared to the previous version. So in other words, for the same site, you may have more severe liquefaction header compared the previous version. So one solution is again, you can do the site-specific response analysis. The code allow you can also, reduce up to 20% the PGA-M based on site-specific response analysis. So now let's talk about the seismic differential sediment. So that's the code language. So just say, in the geotechnical investigation report, if you indicate the differential sediment over a defined length does not exceed the differential sediment threshold specified in table 12.13-3. I put that table on the right-hand side. So, the no 48 is for the risk category 4. So if you look at the equation, it's very simple. It's a 0.002 times L. That's the threshold for the differential sediment. So, and if you read the item 20, so it indicates, if field deep borings are available, then assume half of total sediment across a horizontal distance of 30 feet. So that means they have assumption, they assume the L is 30 feet. And, when you do the liquefaction induced sediment calculation, so you find the worst boring, then you assume half of the total sediment, they are the differential sediment. So if based on this requirement, you can back calculate what is a maximum differential sediment. Based on this requirement, you don't need to worry about the ground improvement. So I just show you the calculation. That's 1.44 inch. So based on the requirement of this item. So in other words, if you calculate the total liquefaction induced sediment or dry soil sediment more than 1.44 inch, or you can run as 1.5 inch. So other than the section 12.13.9.2.1, the still detailing, in some degree you have to consider some kind of ground improvement to reduce the differential sediment. So just keep that in mind. So there is one thing I want to point out, if you look at the commentary of the ASCE 716 for this topic, so this is a figure about what's the definition of the L. So the L actually is the spacing of the column. So one thing I want to highlight this because a lot of essential structures, risk category 4 structure, sometimes you need to have a peer review for the design. So I think, the low 48 made assumption the spacing of the column, minimum space of column is 30 feet. So sometimes you need to double check with the structural engineer if this assumption is correct or not. Sometimes the spacing may less than that. So my suggestion is, if you have peer review on your design, you need to go a little bit conservative. Use the actual L for your design for the differential sediment evaluation. So if you have 20 feet, you will replace the 20 feet in this item 20 to evaluate the differential sediment. So it's very, very important, the size, the geologist, the geotechnical engineer, and structural engineer, they need to kind of work together. They communicate this information so they can know this in the front. So in the later, they can make sure they optimize the design. They don't have to do the costly ground improvement. For the Node 48, so is a need by the geologist with the assistance from geotechnical engineers. So it need the stamp from the California licensed geologist and also the California licensed G for the report. So that's all for today's class. I will provide a link for this Node 48 If you guys have any questions, just leave a comments to me. Thank you very much.